All right, number 3. A 2.1 times 10 to the third kilogram car starts from rest at the top of a driveway that is sloped at an angle of 20 degrees with respect to the horizontal. An average friction force of 4.0 times 10 to the third newtons impedes the car's motion so that the car's speed at the bottom of the driveway is 3.8 meters per second. What is the length of the driveway? So again, we're going to be using the work energy theorem here. Okay, so we have net work going to be equal to whatever the change in the kinetic energy is plus the change in the potential energy is, which we can easily calculate. Now, a bunch of things we know. We know the mass of the car. Just to save some room, I'm going to annotate the things in the actual prompt because, let's face it, we need as much room as we can get. The initial speed is right there. Final speed is right there. Theta is right there. Friction force right there. And then I'm being asked to solve for distance or delta x, however you want to say it. All right, fun stuff. Let's get going. So we're going to consider two things happening here. We're going to consider work being done by gravity and then the work being done by friction. So if we use the work energy theorem, have right here, and we can substitute this in for the work done by gravity. Gravity plus the work done by friction. That's going to be equal to the final kinetic energy plus, gosh darn it, minus, sorry about that, initial kinetic energy. Now, because initial kinetic energy is 0, right? Why? Because it started from rest. We can rewrite this as work done by gravity plus work done by friction is equal to just 1/2 mv final squared. I don't have to take into consideration the initial velocity because it's 0, making that part of the equation 0. Next up, we're going to calculate work done by gravity. So the force due to gravity along the incline, force of gravity along that incline is going to be mass times acceleration due to gravity, and we're going to do sine, right, because it's gravity. And remember, this is from chapter 4, right, sine theta. And so the work being done by gravity along this distance is going to be equal to, again, this thing. This is a force, right? Force due to gravity. Remember, work is force times displacement, so there's a displacement. So I have an equation that I can substitute now in for work done by gravity, which is what I'm wanting right here, work done to gravity. Now I want to get this term right here, work done by friction. Okay. Again, work done by friction is going to be equal to friction force multiplied by displacement. Notice that the negative sign here is indicating that friction is going in the opposite direction of the motion. But check it out. I now have equations that I can plug for here and equations that I can plug for here. And so once I actually do this substituting in here, I can actually start to solve for D. So, let me show my work. So, I'll just do it right here. D sine theta D minus friction force times D. And again, all I did was substitute in these two terms, right? That's right there, and this is right there. The equation is equal to 1/2 mv final squared. Well, in order to make this easy, I can factor the distance out of both of these here. You guys see that? I can make this a lot more simple. Remember, I'm trying to solve for this value. If I have two of them, that makes things complicated. But if I can factor them out, I can make this a lot more simple. So I'm going to factor this out. So I have mg sine theta, and now it's just minus force due to friction. And all that is going to still be equal to 1/2 mv squared, because I haven't done anything with that yet. Divide both sides by mg sine theta minus friction force. Mg sine theta minus friction force. That cancels, cancels, cancels. And I have my equation that I can actually solve, which is, run out of ink. Displacement is equal to 1/2 mv final squared divided by mg sine theta minus friction force. Once I actually do my calculations in here, my mass 2.1 times 10 to the third kilograms. Final velocity. Oh, right here. 3.8 meters per second. I'm going to square that. Mass. Again. Yep, mass again. 2.1 times 10 to the third kilograms. G is going to be 9.81 meters per second squared. What's next? Sine of 20 degrees minus force friction. Watch out for my really well planned out calculations. But when I plug all these values into the calculator, my final answer is going to be 5.1 meters.